Now that we have the product rule under our belt, we're going to go ahead and take a look at the quotient rule. So instead of multiplying two functions together, we are dividing two functions. And again, the rule doesn't work. I can't just take the derivative of the numerator, put it over the derivative of the denominator. Not how it works. We actually have to follow this rule. So the rule for a quotient rule, I have f of x over g of x, is going to look like this. I'm going to take g of x times f prime of x. So I'm taking the derivative of f, multiplying it to g, minus f of x times g prime of x. So numerator times the derivative of the denominator, all over the denominator squared. And that is our quotient rule. General format, no matter what our functions are, it's going to follow this pattern, okay? We can also see this written in a little bit different notation. If I take the derivative of u over v. U and v, again, are just names for functions. So this would look like v times u prime minus u times v prime over v squared. Okay? Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So just a little, almost like a nursery rhyme type thing to kind of help us remember this. We say low d high minus high d low over low squared. Low d high minus high d low over low squared. Okay, again, it's just a little helpful thing to help us remember this pattern. So let's go ahead and take a look at it in action. So my function, I'm going to take the derivative of 2x cubed minus 4x all over x squared. So that setup, you could actually do some algebra and simplify it down, and then you're just left with power rule. That's always an option. If you can simplify it and use easier rules, do it. As long as it is legal math, you can simplify anytime you want. But here, I'm doing this to show the quotient rule, so let's take a look. All right, this is going to equal low d high. So I'm taking the derivative of the numerator, which is 6x squared minus 4, minus high, 2x cubed minus 4x, times the derivative of the denominator, which is 2x, all over low squared. So that's x squared squared. If the question just strictly says take the derivative, I took the derivative. I'm done. That's it. Or if it's a multiple choice problem, we want to be able to make it match the options, in which case I'm going to go ahead and simplify. So I'm going to distribute here and here. So I'm going to get 6x to the fourth minus 4x squared minus 4x to the fourth minus 8x squared all over x to the fourth. And again, so I've got 6x to the fourth minus 4x to the fourth, so that's 2x to the fourth. Negative 4x, take away negative means add, so I'm going to get 8x squared all over x to the fourth. I could leave it here or I could simplify it further. I can factor out an x squared in the numerator. In fact, I can take out a 2x squared, but that's not going to really change much, so we'll go ahead and just leave it like that, which would then simplify to 2x squared plus 8 over x squared. But again, at any point in there, the algebra is solid, unless I made a mistake, and you're good to leave the derivative as is. So I'm going to squeeze in one more example here in my open space, and then hopefully that'll help you with future problems. So I am going to take the derivative of 5x squared minus 3 over e to the x. Okay, so low d high minus high d low. Notice I put this in parentheses because I need to be able to subtract this whole piece, and I'm multiplying by that e to the x. All over low squared. Okay, at this point, if it's just take the derivative is done, you're good to go. I'm going to go ahead and simplify. I can factor out this e to the x here. So I'm going to have e to the x times 10x minus 5x squared plus 3 all over e to the x squared. My e to the x and my square cancel, and I get negative 5x squared plus 10x plus 3 all over e to the x. Make sure you're practicing your algebra, but most importantly, make sure you are checking out that quotient rule. Good luck.